In our example number 2, use the functional relation of S of n equals 3n minus 2, where n is a natural number, to write an infinite sequence. So S of n is equal to 3n minus 2. So you will give the values of n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and so on. Okay? So if S of n is 1, S of 1 is equal to 3 times 1 minus 2 equals 3 times 1 equals 3 minus 2 equals 1. If n equals 2 equals 3 times 2 minus 2 equals 3 times 2 equals 6 minus 2 equals 4. If n equals 3 equals 3 times 3 minus 2 equals 9 minus 2 is 7. If n equals 4, 3 times 4 minus 2. 3 times 4 equals 12 minus 2 equals 10. If n equals 5, that is 3 times 5 minus 2 is 15 minus 2 equals 13. Okay? So the sequence is 1, 4, 7, 10, 13, and so on, because this is infinite sequence. Okay, for number 3, using n equals 1, 2, 3, 4, and 5, write the first 5 terms of the sequence defined by S of n equals n squared minus 1 over n. If n is equal to 1, then 1 squared minus 1 over 1 equals 1 squared is 1, 1 over 1 is 1, equals 0. If n equals 2, 2 squared minus 1 over 2. 2 squared is 4 minus 1 half equals 3 and 1 half, or equals 7 halves. Then if n equals 3, equals 3 squared minus 1 over 3 equals 9 minus 1/3 equals 26 over 3. Okay, that is 3 times 9 minus 1 equals 26 over 3. Next, if n equals 4, 4 squared minus 1/4. 4 squared is 16 minus 1/4 equals 63 over 4. Next, if n equals 5, equals 5 squared minus 1/5 equals 25 minus 1/5 equals 5 times 25, 125 minus 1, 124 over 5. So the first 5 terms are 0, 7 halves, 26 over 3, 63 over 4, 124 over 5. So the sum of this you will add all of this. 0 plus 7 halves plus 26 over 3, 63 over 4. This is plus 124 over 5. Okay, you don't have to find the sum.